In the autumn of 1941, somewhere on the Eastern Front between Smolensk and Moscow, a German infantryman did something that no official protocol had authorized and no training manual had recommended. He picked up a Soviet rifle from beside a dead Red Army soldier, examined it briefly, charged the action, and slung it over his shoulder alongside his own Karabiner 98. He carried it for the rest of the day. That evening, at a rest position behind the advancing line, he showed it to his section leader. The section leader turned it over in his hands, operated the bolt, inspected the mechanism, and asked where he could find more of them. Within weeks, that question was being asked at every level of the German infantry on the Eastern Front, from individual soldiers who had picked up the weapon in the field to battalion commanders who were finding captured examples in their unit's armories to ordnance officers in Berlin who were receiving formal requests for ammunition supply for a weapon that Germany had not built, had not authorized, and could not officially acknowledge its soldiers preferred to their own. The phenomenon was widespread enough to generate official documentation. German division-level quartermasters began including the 7.62 by 54 mm rimmed cartridge, the standard Soviet rifle round, on their ammunition requisition forms alongside German standard calibers. This was bureaucratically unusual. An army's logistics system is built around its own weapons. Adding a foreign caliber to the supply chain meant acknowledging that a meaningful number of soldiers were carrying foreign weapons, which meant acknowledging that those soldiers considered the foreign weapon preferable to their own. The Wehrmacht's logistics apparatus, famously rigid, adapted because it had no choice. The soldiers carrying captured SVT-40s were not going to stop, and denying them ammunition would have reduced the combat effectiveness of units that needed every rifle firing. The problem was eventually formalized. The Wehrmacht issued a technical manual for the SVT-40 in German, with German language instructions for disassembly, cleaning, gas regulator adjustment, and maintenance procedures. A printed, official, Wehrmacht-issued manual for a Soviet weapon. Think about what that means. An army that had conquered most of Europe was publishing instruction manuals for the enemy's rifle, because its own soldiers preferred it. The weapon was the SVT-40, Samozaryadnaya Vintovka Tokareva, the self-loading rifle of Tokarev, model 1940. A gas-operated semi-automatic rifle chambered in the standard Soviet 7.62 by 54 mm rimmed cartridge. It weighed 3.85 kilograms unloaded, lighter than the German Karabiner 98, lighter than the American M1 Garand, lighter than any other self-loading rifle in service anywhere in the world. It held 10 rounds in a detachable box magazine, could be reloaded with standard 5-round stripper clips through the top of the open action, and could fire between 25 and 40 aimed rounds per minute in the hands of a competent operator, roughly 3 times the rate of a bolt-action rifle. The man who designed it was 69 years old. He had been designing firearms since the age of 18, when he had apprenticed at the Sestroretsk arms factory in the final decade of the Russian Empire. His name was Fyodor Vasilyevich Tokarev, and by the time the SVT-40 reached the front lines, he had been building weapons for longer than most of the soldiers who carried them had been alive. To understand why Germany's soldiers were collecting Soviet rifles from battlefields, an activity that, under normal military discipline, would have been considered at best eccentric, and at worst a violation of standardized equipment protocols, you have to understand what the Karabiner 98 actually felt like to fire in combat in 1941. The K98 was, by every objective measure, one of the finest bolt-action military rifles ever manufactured. It was accurate to ranges well beyond what infantry combat typically demanded. Its action was smooth, reliable, and nearly impervious to dirt and mud. Its manufacturing quality, even in mid-war production, was high enough that any individual K98 could be expected to function for decades without significant maintenance beyond basic cleaning. German soldiers trusted the K98. They did not love it the way a man loves a tool that makes his work easier. They respected it the way a man respects a tool that is reliable, but fundamentally outdated, aware that it works, aware that it has always worked, and equally aware that the world has moved on and the tool has not. The K98 fired 1 round per trigger pull. After each shot, the soldier lifted the bolt handle, pulled it rearward against a spring, pushed it forward to strip the next round from the internal magazine and locked it down. 4 movements. In controlled conditions, a firing range, warm weather, no incoming fire, a trained soldier could perform this sequence in roughly 1 second. In combat, with adrenaline making fine motor control unpredictable, with gloves required in winter that made the bolt handle difficult to grip, with mud and ice fouling the mechanism, with the fundamental psychological reality that every time the soldier lifted his bolt handle, he took his eye off the target and exposed his hand above the rifle's profile. The practical rate of fire dropped to 8 to 12 aimed rounds per minute, A German squad of 10 men with K-98s could produce roughly 100 aimed rounds per minute. A Soviet squad of 10 men with SVT-40s could produce 300. Pause and think about what that means. The same number of men, the same positions, the same tactical situation, 3 times the fire output. German soldiers did not need to read an engineering report to understand this. They heard it. The sustained crack of semi-automatic fire from Soviet positions sounded different from the slower rhythm of bolt-action fire, and the difference was the difference between positions you could suppress by outfiring them and positions you could not. Fedor Tokarev was born on the 14th of June, 1871, in the village of Yegolikskaya, in the Don Cossack region of the Russian Empire. His father was a Cossack farmer. The family had no particular connection to engineering or manufacturing. Tokarev's first contact with firearms was the standard Cossack experience. He learned to shoot and ride before he learned to read fluently, because in the Don Cossack communities of the late 19th century, these were considered more immediately useful skills than literacy. What set him apart was not his shooting, but his curiosity about the mechanism. Other boys fired the rifle and moved on. Tokarev fired the rifle, and then took it apart to understand why it had fired. He was not content to use a machine. He needed to know how it worked, and once he knew how it worked, he immediately began thinking about how it could work differently. He apprenticed at the Sestroretsk arms factory at the age of 18, qualified as a master gunsmith by his mid-20s, and began submitting weapon designs to the Imperial Russian Army, while still technically a factory worker rather than a designer. His early submissions were rejected, not because they were poor designs, but because the imperial procurement system was not structured to accept designs from factory floor workers without formal engineering credentials. Tokarev did not have credentials. He had hands that could feel a mechanism's tolerances to within thousandths of an inch, and a mind that could visualize how those tolerances would change under heat, cold, dirt, and the stress of repeated firing. He continued submitting designs. He continued being rejected. The revolution of 1917 changed everything for Tokarev, as it changed everything for every Russian. The old procurement system, with its emphasis on credentials and social standing, was swept away. The new Soviet system, for all its flaws, evaluated weapons designs on performance rather than the designer's background, partly out of ideology, partly out of desperation, because the civil war that followed the revolution required weapons in quantities that the old system could never have produced. Tokarev's designs began receiving evaluation on their merits. He thrived. The TT-33 pistol, the Tula Tokarev, model 1933, became the standard Soviet military sidearm throughout the Second World War. It was a compact, powerful handgun chambered in 7.62 by 25mm, heavily influenced by the Browning system, but redesigned for simpler manufacturing and colder climates. Soviet officers carried it from Stalingrad to Berlin. It was not elegant. It was reliable in conditions that would have jammed more refined pistols, specifically at temperatures below -30 where other mechanisms froze. The SVT-38, the predecessor to the SVT-40, came next, a semi-automatic rifle that the army tested extensively and found promising but mechanically overcomplicated. Tokarev took the criticism, simplified the design significantly, removing unnecessary components, reducing the number of parts, making field stripping faster, and resubmitted it as the SVT-40. By the time the war began, Tokarev had been designing firearms for 50 years, and the weapon he considered his finest work was already in the hands of the soldiers who would either prove it or destroy its reputation. The SVT-40's gas operating system was both the weapon's greatest engineering achievement and the source of its most persistent reputation problem. The system worked as follows. When a round was fired, a small amount of propellant gas was tapped through a port drilled in the barrel, approximately 2/3 of the way to the muzzle. This gas entered a cylinder mounted above the barrel and drove a piston rearward against a return spring. The piston, connected to the bolt carrier through a linkage, unlocked and drove the bolt to the rear, extracting and ejecting the spent case. The return spring then drove the bolt carrier forward, stripping a fresh round from the magazine and chambering it. The entire cycle took a fraction of a second. The soldier's only action was to pull the trigger again. Think of it like a steam engine. Hot gas enters a cylinder, pushes a piston, and the piston's movement drives a mechanical action. The difference is that in Tokarev's system, the gas comes from the weapon itself rather than an external boiler, and the cycle repeats with every shot rather than every rotation. The gas regulator was the key component that separated Tokarev's system from simpler designs. It was a small adjustable valve near the gas port that controlled how much propellant gas entered the piston cylinder. Different batches of ammunition produced different gas pressures. Wartime Soviet ammunition varied significantly in quality, with propellant charges that could differ by 10 to 15% between batches manufactured at different factories or in different months. A fixed gas port, one that could not be adjusted, would need to be sized for the weakest possible ammunition, which meant that stronger ammunition would drive the piston too hard, hammering the bolt against the rear of the receiver and accelerating wear on every moving part. The adjustable regulator let the soldier tune the gas flow to match whatever ammunition was available. Less gas for strong ammunition, more for weak. The engineering logic was impeccable. The practical implementation required a soldier who understood what the regulator did, why it mattered, and how to adjust it. This was the fracture point between Tokarev's design intent and Soviet wartime reality. The engineering sophistication of this system was considerable, and it is worth comparing it directly to the American M1 Garand to understand why the SVT-40 represented a different, and in some respects more advanced, approach to the same problem. The Garand used a long-stroke gas piston. The piston and the operating rod were a single unit that travelled the full length of the bolt's rearward movement. This meant more mass moving inside the rifle with each shot, which produced more felt vibration but also made the system extremely forgiving of manufacturing variations and ammunition inconsistency. The long-stroke piston hammered the bolt rearward with a sustained push that would cycle the action reliably even when the gas port was partially fouled or the ammunition was below specification. The SVT-40 used a short-stroke gas piston. The piston moved only a short distance, approximately 40 mm, imparting a sharp impulse to the bolt carrier, which then continued rearward under its own momentum. Think of the difference between pushing a billiard ball across the table by keeping your hand on it for the full length of the stroke and flicking it with a sharp tap of the finger. The long-stroke system is more predictable and tolerant of dirt. The short-stroke system is lighter, produces less vibration in the receiver, and allows the gas components to be smaller and more compact, which matters when every gram of weight affects how long a soldier can carry the weapon before exhaustion degrades his combat effectiveness. The trade-off was that the short-stroke system required more precise manufacturing, because the bolt carrier's momentum had to be exactly calibrated. Too little impulse, and the bolt would not travel far enough rearward to extract and eject. Too much, and it would slam against the rear of the receiver with enough force to damage the mechanism over time. Tokarev chose the harder path because it produced a lighter weapon. He trusted his manufacturing to hold the tolerances. Under peacetime quality control, the trust was justified. Under wartime conditions, with factories evacuated east of the Urals and running triple shifts with untrained workers, the tolerances sometimes slipped, and here is where the SVT-40's reputation problem emerged. The weapon worked beautifully in the hands of well-trained soldiers who understood how to maintain it. The gas regulator, a small adjustable component near the gas port that controlled how much gas entered the piston cylinder, needed to be set correctly for the ammunition being used and the cleanliness of the barrel. Different batches of Soviet wartime ammunition produced different gas pressures, and the regulator needed adjustment to compensate. A soldier who understood the gas system could tune the weapon to function reliably, with whatever ammunition was available. A soldier who did not understand the gas system, who had received minimal training, who had been conscripted from a collective farm 3 months earlier and given a rifle he had never seen before, would fire the weapon until it malfunctioned, declare it unreliable, and pick up a Mosin Nagant bolt action from a supply dump because the Mosin Nagant required no understanding beyond load, aim, fire, work the bolt. The SVT-40's reputation for unreliability was not, in the main, an engineering failure, it was a training failure. The weapon was too advanced for the training system that was supposed to prepare soldiers to use it. The irony is brutal. German soldiers, trained to a higher standard of individual weapon maintenance than Soviet conscripts, picked up SVT-40s from battlefields and found them reliable, accurate, and mechanically impressive. The Wehrmacht's Ordnance Evaluation Laboratory, Waffenamt, obtained captured SVT-40s and subjected them to systematic testing at the Kummersdorf proving ground outside Berlin. The report, which survives in translated form in several military archives, called the design clever, well suited to mass production, and effective within its intended operating parameters. German engineers noted the short-stroke gas system with particular interest, because Germany's own attempts to develop a semi-automatic infantry rifle, the Gewehr 41, used a less elegant gas trap system that required the muzzle to be sealed with a complicated cup-shaped device that was difficult to clean, prone to carbon fouling, and mechanically fragile under sustained fire. The Gewehr 41's gas trap system was, by the assessment of the engineers who designed it, an engineering compromise that had been chosen because no better solution was available at the time. When Germany eventually produced the Gewehr 43, a functional semi-automatic rifle that entered service in late 1943, the gas trap system was gone. In its place was a conventional gas port drilled in the barrel, feeding a short-stroke piston through a cylinder mounted above the barrel, a system that was, in every significant respect, a direct reproduction of Tokarev's design. The German engineers did not merely acknowledge the influence. The internal Waffenamt documentation refers explicitly to the SVT-40's operating mechanism as the basis for the Gewehr 43's action. They copied his homework, they put it into production, and they never publicly credited the source. The Soviet Union, whose soldiers were struggling to maintain the rifle that the enemy was enthusiastically copying, was simultaneously pulling SVT-40S from frontline infantry units and replacing them with the simpler Mosin-Nagant bolt action. The decision was not made lightly. Soviet commanders understood that they were taking a step backward in infantry firepower, but the practical calculus was straightforward. A weapon that worked in 50% of your soldiers' hands was less useful than a simpler weapon that worked in 95% of your soldiers' hands. The SVT-40 was not retired. It was redistributed, away from general infantry toward the units that could use it properly. The SVT-40 found its most appropriate home not with the general Soviet infantry, but with three specific groups that had the training and the motivation to maintain it. The first was Soviet naval infantry, the Marines, professional soldiers who received extended training and who treated their weapons with a craftsman's attention. The SVT-40 in Marine hands was devastating. At Sevastopol, where Soviet Marines defended the Black Sea naval base for 250 days against overwhelming German assault, SVT-40 equipped units provided sustained semi-automatic fire from fortified positions that German infantry found extremely difficult to suppress. At Stalingrad's factory district, Soviet Marines armed with SVT-40S fought in the ruined buildings of the Barricades factory and the Red October steelworks, where the engagement ranges were so short and the tempo so violent that the difference between 8 rounds per minute from a bolt action and 30 rounds per minute from a semi-automatic was measured in survival rather than statistics. The second group was the snipers. Soviet sniper doctrine produced more designated marksmen than any other army in the war. Thousands of trained snipers deployed across every front, operating in pairs, targeting German officers, machine gun crews, artillery observers, and communications personnel. The standard Soviet sniper rifle was the Mosin-Nagant with a PU scope, a bolt-action weapon that was exceptionally accurate, but limited to the same one-shot then work the bolt cycle as every other bolt-action rifle. The SVT-40 sniper variant, fitted with the same PU 3.5 power telescopic sight, gave Soviet snipers something the Mosin-Nagant could not provide, a rapid follow-up shot. A bolt-action sniper fires, the target drops, but if the first shot misses or only wounds, the target has 2 to 3 seconds while the sniper works the bolt to find cover, crawl away, or fire back. A semi-automatic sniper fires, and if the first shot misses, the second arrives less than a second later, without the sniper removing his eye from the scope or his cheek from the stock. The window for the target to react shrinks from seconds to fractions of a second. Lyudmila Pavlichenko, the most famous Soviet female sniper, credited with 309 confirmed kills, used a Mosin-Nagant. Other snipers, whose names are less well known because they survived the war without the propaganda attention that Pavlichenko received, preferred the SVT-40 specifically for the follow-up capability. The debate between bolt-action precision and semi-automatic speed was never fully resolved during the war. It continues among competitive shooters today. The third group was the Finnish army. When the Soviet Union invaded Finland in the Winter War of 1939, thousands of SVT-38s and SVT-40s were captured by Finnish forces who found themselves, like the Germans a year later, holding a weapon that was mechanically superior to their own standard rifles. Finnish soldiers adopted captured SVT-40S with enthusiasm. The Finnish army even developed its own maintenance manuals for the weapon and standardized its use within specific units. A weapon designed to fight Finland was captured by Finland and used against its designers. The irony was complete. Let me put you in the boots of a German corporal in a reserve infantry division near Rzew in the winter of 1942. You've been in the line for 3 weeks. The temperature has not risen above -20 degrees in 8 days. Your breath freezes on the scarf wrapped around your face. The metal parts of your K98 are so cold that touching them with bare skin removes the skin. Your bolt is stiff. The lubricating oil has thickened to the consistency of honey, despite using the light winter oil that the quartermasters issued, and every bolt manipulation requires deliberate force applied with gloved hands that slows your firing rate further below the already slow peacetime standard. a replacement soldier in your section, a Gefreiter from Bavaria who spent 2 years on the factory floor at Moserwerke before his conscription papers arrived, has been carrying a captured SVT-40 since October. He maintains it meticulously. He cleans the gas system every evening by candlelight in the bunker, disassembling the gas cylinder with a screwdriver and wiping the piston with a rag soaked in German weapon oil. He adjusts the gas regulator when new ammunition arrives, turning the small dial near the muzzle with a cartridge tip, testing the action, adjusting again. His SVT-40 fires 3 aimed rounds in the time your K98 fires 1. He has offered twice to show you how the gas system works. You declined both times because you were not going to carry a Soviet weapon. On the 3rd morning, after a night when a Soviet probing attack reached your trench line, and you emptied your 5-round internal magazine in 4 seconds, worked the bolt 4 times to reload from a stripper clip with fingers so cold, you dropped the first clip into the mud, emptied the magazine again, and spent 12 additional seconds reloading from your 3rd clip, while a Soviet soldier with a fixed bayonet was 15 meters away and closing at a sprint. You accept his offer. That evening, the Bavarian shows you the gas regulator. He shows you the disassembly procedure. 14 steps, none requiring tools beyond a cartridge tip and a cleaning rod. It takes 20 minutes. The rifle is 300 grams lighter than your K98. It holds 10 rounds in a detachable magazine that you can swap in 3 seconds. You do not work the bolt between shots. You pull the trigger and the mechanism does the rest. You never go back to the Karabiner 98. Your section leader does not comment. 3 other men in the section are already carrying SVT-40S. Fedor Tokarev worked through the war at the Izhevsk mechanical plant, where SVT-40 production continued until 1945. Over 1,600,000 produced in total, making it the 2nd most produced semi-automatic rifle of the war, after the American M1 Garand. He was awarded the Hero of Socialist Labour in 1940, before the German invasion, in recognition of the SVT-40's design and production. He received the Stalin Prize in the same year. He was appointed to the Supreme Soviet, the Parliament of the USSR, an honour that was primarily ceremonial, but that reflected his status within the Soviet engineering establishment as a national treasure. Unlike many Soviet designers of his generation, Tokarev was never persecuted during the purges. His value to the state as a weapons designer was so evident that even the paranoid machinery of Stalinist security left him unmolested. He continued designing weapons into his 80s, submitting proposals and attending trials with the energy of a man who had never imagined doing anything else. He died on the 7th of June 1968 at the age of 96, outliving every other major firearms designer of his generation by decades. He had been designing weapons for 78 years, from the Russian Empire to the space age, from black powder cartridges to the nuclear era. He never stopped. The unexpected tangent, the SVT-40's short-stroke gas piston system, the mechanism that Tokarev designed and that Germany copied for the SVT-43, did not die with the rifles that used it. The operating principle migrated westward after the war, carried by captured examples, engineering reports, and the quiet conversation that occurs between weapons designers of different nations when the shooting stops and the analysis begins. The same short-stroke gas piston principle appears in the FNF-AL, the Fusil Automatique Léger, designed by Dieudonné Save at Fabrique Nationale in Belgium, which became the standard-issue battle rifle of over 90 NATO and Allied nations during the Cold War. It appears in the Heckler & Koch G3 system. It appears in the FN SCAR, the Special Operations Combat Assault Rifle, currently in service with United States Special Operations Command. It appears in the Beretta ARX-160, in the Remington ACR, in the HK-416. Every modern military rifle that uses a short-stroke gas piston, and that includes an increasing proportion of the rifles carried by Western Special Forces in the 21st century, is using an operating principle that traces its lineage through the Gewehr 43 back to a Cossack gunsmith in a Soviet factory who had never attended an engineering university, but who understood gas dynamics, piston mechanics, and the behaviour of metal under stress better than most of the degree-holding engineers who evaluated his work. Nobody credits Tokarev. The principle does not carry his name. The textbooks call it a short-stroke gas piston system and move on, but the lineage is there, and the lineage matters, because the engineering decisions a 69-year-old Russian made in 1938 are still determining how soldiers fire their weapons 88 years later. Germany could not stop collecting his rifles from the battlefield. Germany could not stop copying his engineering. Finland captured his rifles and used them against him. The Soviet Union's own army could not train its soldiers well enough to use the weapon properly. And 88 years later, the engineering world still has not stopped building on what he started. They called it unreliable. They were wrong about the rifle. They were right about the soldiers. The rifle just needed better hands. And everywhere it found them, German, Finnish, Soviet Marine, or modern special forces, it worked exactly as a 69-year-old Cossack gunsmith had designed it to.